Now, symbolics represent a vehicle that we can use to change values within a proc without having to go in and edit them. So as an example, the proc then can define variables that we can use. And as a result of these variables then, we can set default values, and we can use that then as parameters that can be passed if we want to change those particular values. We use a single ampersand to indicate that a particular value is a variable. And that's what we will then have a default value assigned for, and it's something that we can code with a replacement value when we execute that particular proc. The symbolic parameters themselves must be identified on the proc statement and have a default value associated with them. And as a result, when we do something like that, we can have a proc like this. Now this again is showing an in-stream proc with a symbolic definition for the member name. So notice that on the proc statement, we have a member equals dummy indicating the default value in the event that nothing is specified on the execute statement. You can see our sysut1 is identifying user.parmlib, and the member name in this case is a symbolic value. And then you can see that after the pen statement, we invoke this proc 4 separate times, each time specifying a different member name. So that means the first time we run it, we're going to run this with member equals name1, the second time with member equals name2, and so on. This allows us to use the same proc, but in fact print 4 different members. And this is the role that symbolic values have, because they will be substituted with JCL expansion, and as a result, you can see we've made a modification to this proc without actually having to modify the code itself. In this case, you can see where the symbolic substitution can come from. Notice that we execute our gen proc. We have a default value here of member equals jes2parm and user equals user. And when you look at the JCL, you'll see a message indicating substitution JCL. And you can see that the member name is a symbol, and that's been replaced with jes2parm, which was our default. And you'll see that user is also a symbol, and that's been replaced with user. The one thing that's unusual here is you'll notice that when we have the variable name like this, we have 2 periods. And the reason why we have to do that is so that this lets the system know that this is a level within a data set, and therefore to preserve the period that separates the high level from the low level of the data set name. If there was only a single period coded, what would end up happening is that the variable user would simply be appended to parmlib, and they would be run together. So in this particular situation, you would need to specify 2 periods in order to produce the substitution result that you really want. In this example here, you can see we've even gone a step further by adding a variable to the keyword itself, so that in this case, the symbolic DSN is substituted with the value DSN. And so in this case here, what we have then is we have the substitution showing DSN equals user.parmlib and jes2parm as the member that's being referenced. Now this is kind of an extreme example, but it illustrates the power of symbolics. The main caution here is that you don't want to get carried away with using symbols. Because in a simple instance like this, where we have a single step, it's pretty straightforward to see what values we have, which ones we likely need to change, and therefore which ones we're going to benefit from primarily by having a symbolic value. However, if we get too creative and we start putting too many things as symbols, 1, it can become confusing and difficult to remember, and 2, we start running into the problem then of parameters that might be common throughout the proc itself, and suddenly, introducing changes that we never really intended. So as a result, in this case, since each of the DD statements is unique, we don't have any overlap, we don't have any redundancy, and as a result, we can code pretty much whatever we want, and it could conceivably work, even if it does seem to be overkill. But as an example here, DSN, in this case by being equal to DSN, even though it shows as a substitution, in reality there's nothing else we could actually ever specify there. Dataset name is the only legitimate parameter that we can code for a dataset name. So therefore, even though we can create a symbolic, it makes no sense to do that in any practical sense. So that's one of the reasons why we have to be very, very careful when we start assigning symbolics, so that we also focus on the usability aspect of it rather than just creating a big confusion about symbolic parameters. And bear in mind that with some of these production procedures, they can get to be quite lengthy. And so in this case, where we're looking at, 6, 7 statements, this is not necessarily a big concern. But if you were dealing with procs that might have several hundred statements, then suddenly keeping track of a large number of variables and symbolics that may not necessarily make sense or may have been poorly designed, then your ability to use them becomes compromised because there's simply too much information to keep track of. So you want to use this in a way where it's extremely practical and can provide value rather than simply doing it because you can.